Okay, so this is number 2. This is the second kind of factoring. The first kind we've already done, and that's Gcf factoring, right? And we remember what that is, right? We've practiced that a few times. It's what we've done lately. It's what we were just doing. Everyone's cool with Gcf factoring, right? Okay. You've also done trinomial factoring, but only with a picture. You did it right here. Okay? You actually know how to do trinomial factoring with a picture. But today, we're going to get rid of that. We're going to do this algebraically. Okay? So, first thing we got to do here is recognize this is binomial times a binomial, yeah? Expand that. It should take you about 2 seconds because you don't need to FOIL it because you can use the shortcut. So what is this answer? X squared plus 10x plus 24, right? Everybody can do that, yeah? If you had to FOIL it, you could FOIL it too. This is what we call a trinomial, all right? We know that as well. Now, the next thing, now we're going to do some math terminology, okay? This guy has a name. It's not important for grade 10, okay? This guy is the quadratic term. That is not an important word for grade 10. But we also call him term A. That is important for grade 10. Okay? This guy is called the linear term. Not incredibly important grade 10, but we also call him B. Very important. And this third guy is the constant term. And we also call him C. Everybody cool? This terminology, A, B, and C, gives us what we call general form of trinomials. And it is ax squared. Some coefficient and a quadratic term plus bx, some coefficient and a linear term plus c, a constant. Okay? Now, in the trinomials that we are using today, is there a value for A?
No.
What value would go right there? Because that's what 1. Everybody cool?
Yeah.
So the trinomials we are going to be factoring today, A equals 1. So it's still there, but it's only 1. Everybody cool? All right. Now, the next thing. You're not going to write this down. Think in your own words about explaining to me this shortcut. Why am I able, without doing FOIL, when it looks like this, to get to the trinomial in 1 second? What am I doing? Vanessa?
You're adding the constants together first, and then you're multiplying the
Right.
constants.
I add the constants to get the linear term, and I multiply the constants to get the constant term. Easy peasy, yeah?
That has to be the constant.
Yes, it has to be the constants. Everybody cool with that? That's the shortcut, agreed? And that expands these two binomials, yeah? Well, I've already told you factoring is the reverse of expanding, yeah? So, if step 1 is add the constants, and this is to expand, right? If step 1 is add and step 2 is multiply, then if I want to go backwards, what do I deal with first? The multiply, then the adding, correct? So, let's look at this question right here. Is that a trinomial?
Yes.
Is it in general form?
Yes.
Is it in the general form that we are learning today?
Yes.
Yes, because it's got an a value of 1. Everybody cool? Now, I know that if it factors, it's going to end up looking like this, right? X, X, and then a plus and a minus with constants, correct? Now I know I got to go backwards through these steps, right? So I got to deal with the multiply of the constants first.
So you divide?
So I need two numbers that will multiply to negative 18.
9 and negative 2.
All right? So I need to multiply to negative 18. Now, the second part of this, those same numbers have to add to what? The 7. Now, Josh tells us it's 9 and negative 2. Is that true? Negative 9, or 9 times negative 2 is negative 18, correct? And 9 plus negative 2 is 7. So he's right. It is x plus 9 and x minus 7. Now let's check. Is 9 minus 2. Is 9 minus 2 7?
Yes.
Yes. Is 9 times negative 2 negative 18?
Yes.
So he's right. Does everybody see? It's the reverse of FOIL.
So bad at this though? I can't think of numbers.
I know. There's a reason you're bad at this if you're bad at this.
I can do my times table.
No.
No, the multiplication.
It's the multiplication, Bryce. It really is. And I'm going to tell you guys a story about this. About 7 years ago, I had a kid in my grade 9 class. Kid, what's 4 plus 3? I don't know. Kid, what's negative 12 plus 7? I don't know. Kid, what's 3 minus 21? I don't know. That's the level of computational ability this grade 9 kid was at. Now this factoring stuff used to be in grade 9. We got to factoring. By the time I finished writing out the example, the kid already knew. Just like Josh did. He went, negative 9 and 2, right away. And then I said, hey, you're absolutely right, kid. Now write down the answer. I can't. What? I don't know what the answer is. He couldn't do this part. He knew the two numbers immediately, but couldn't do that. Weird, hey?
What did you do then?
Well, what do you mean, what did I do? I can't. I said practice. You can find the numbers. That's the hard part. Everyone else in the class is going, 7 times. And he's like, 7 and negative 2. And then the rest of the class would go, oh, x plus 7, x minus 2. And he'd be like, It was very strange. So, look at this next one. What do I need to multiply to? Negative 8. And what do I need to add to? Look again. Negative 2. What are the two numbers? Well, I know it's got to be x and x. Okay. Now, what are the numbers that will multiply to negative 8 and get to 2? Some people see it right away, other people don't. So here's what I like to do. I start with 1. Can 1 and 8 go together to make 2 in any way?
No.
No. Because you're going to get 7 or 9 when you put 1 and 8 together, right?
Yeah.
What's the next one? 2 and 4. Can 2 and 4 in any way make 2?
Yes.
Yes.
4 to 14.
I need negative 2.
Negative.
So it's plus 2 take away 4. Got it?
Yeah.
And then we check. 2 minus 4 is negative 2. 2 times 4 is negative 8, and we're good. Everybody cool? If you're not able to see this in your head, then you got to factor. 1 and 8. Well, that's never going to get me to 2. 2 and 4. Oh, that can get me to 2. Does everyone see how to do it? You already know how to factor from a radical unit. Okay, now let's look at C. Look closely at C and tell me what's different from A and B. Do they have a quadratic term? Yeah. They have a linear term, they have a constant. There is something different. I'll get out my highlighter. This one's positive. So what am I multiplying to now? To a positive 35. And what am I adding to? Negative 12. So I know it's going to be x and x, because I need that x squared. Now, will 1 and 35 get me there?
No.
5 and 7? Right. Negative 7, negative 5. Now, look closely. When that guy was negative, when my constant was negative, what were my signs in my answer?
Positive and negative.
Different, right?
Yeah.
My constant is negative. What are my signs?
Different.
Different. My constant is positive. What are my signs?
Negative.
The same. What if this guy was positive 12? Then what would they have to be? Plus 7.
And then minus plus 5.
Plus 5. Because then I would have 7 plus 5 to get positive 12. Everybody cool? Okay. D and E are exactly the same as A, B, and C, except the letter is different.
Yeah.
So do you think you changed the rules?
No.
No. So what do I got to multiply to in D?
20.
Negative 20. What do I got to add to? Positive 12. So what is it? What are the factors of 20 that add to 12? Will 1 and 20 do it? Will 2 and 10?
Yes.
2 and 10 is where you want to check, right?
Yeah.
So, since that's negative, it must be A plus 10 and A minus 2, correct?
Yeah.
Or it must be A minus 10 and A plus 2. It has to be one of those two, doesn't it? But it doesn't work, does it? Because when you check, 10 minus 2 is not 12, and negative 10 plus 2 is not 12. So is this factorable? No. That's wrong. That's wrong. So this does not factor, which is perfectly legitimate answer. I have seen kids spend 10 minutes on this because they aren't learning why. They're learning what to do. Do you understand the difference? They say, well, it has to be 10 and 2. 10 and 2 makes 20. Ah! And then they sit there for 10 minutes looking at trying to make 10 and negative 2 make positive 12 without ever understanding maybe it doesn't factor. Right? Kind of like when we're doing radicals. Does root 21 get any simpler? No, because it's 3 times 7. So you leave it like that. Understand? This doesn't get any simpler. So we leave it like that. Cool? All right. Now, is there anything weird about E? It's just a different letter. So do we change the rules? Nope. What do I got to multiply to? Negative 14. What do I got to add to? Negative 5. Since that's negative, I know it's y plus and y minus, yeah?
Yeah.
What are they?
Negative 7 and 2.
Has to be negative 7 and positive 2, doesn't it?
Yeah.
2, negative 7. Is 2 minus 7 negative 5?
Yes.
Is 2 times negative 7 negative 14?
Yeah.
So we're right. Everybody cool? All right, now listen to me. Every single question from here on, you know how to do, but they look different. So let's look at F. What's wrong with F? It's got this guy right here. We only know how to factor when A equals what? 1. A does not equal 1 here. A equals 4. But I gave you another factoring tool that you're supposed to try every chance you can. GCF. What is the GCF here? 4. So I'm going to divide everything by 4. Now you guys are smart kids, but you're going to make this error. Is that 4 disappearing? No, because we have to write it out, we remember, as GCF bracket, then all of our quotients, right? Plus quotient, plus quotient. So I got to rewrite this as 4x squared minus 5x minus 14, right? Now, you guys are smart kids, look at this. And look at that. Are they the same? So remember how I said when you're GCFing, sometimes you have to go further? This is the first example of it. That factors. How do we know it factors? Well, we just did it. So this answer is what? Can we forget about 4? No. And we know this becomes x plus 2 and x minus 7. Does everyone see how it works? If you could do E, you can do F. Yeah? All right. So you guys look at G. What's wrong? Same thing. So we got to get rid of that number that's in front of x, right? The only way to get rid of 10 times something is to divide. Now I got to check. Does 10 work with everything?
Yeah.
So we can go ahead and do that, can't we? Divide everything by 10, and we rewrite 10 x squared plus 8x plus 12. Now I got to check. Check all trinomials. Is there a number, a pair of numbers, that multiplies to 12 and adds to 8? It is 2 and 6. X plus 2, x plus 6. Now I'm going to ask a favor of the people that are starting to see these pairs really quickly. Please don't say it out loud. Other people need to. Just write it down. Okay? Let's look at the next one. What's ugly? It's a negative 4. What do I want to get rid of? The negative 4. So I check. Will negative 4 multiply into all of these? Yes. So I'm going to divide everything by negative 4. Can I forget about the negative 4? No, it goes here. Now, here's where you're going to mistake. What do 2 negatives get? Positive, so that's just t squared. What do 2 negatives get? So it's positive 4t. What does a negative and a positive get? Negative 32. And then I say to myself, self, that's a trinomial, and it's got a 1 where the a should be. Do I need to check that for factoring? Yes or no, guys? Yes. What do I got to multiply to? Negative 32. What do I got to add to? 4. Don't say it out loud. I'm going to wait for a moment to let everybody have a crack at it. Remember, if you don't see it automatically, just start at 1 and 32. Not going to do it. 1 and 32 will not make 4. Will 2 and 16 make 4? No. 3 doesn't go into 32. 4 times 8, will that make 4? There it is, right? I need positive 4, so it must be 8 minus 4, correct? So it's t plus 8, t minus 4. Is everybody Gouda? Nobody is Swiss? Can I slide along? All right. Now look at I. What's different?
There's no
variable.
It's backwards, isn't it? What should go first?
The d squared.
The d squared. So let's rewrite it. Negative d squared minus 5d minus 24. Now what's ugly? There's a negative in front of the d. What do I need in front of the d to do this? Nothing, right? So I got to get rid of that negative. What's the number that we don't write?
What?
Negative 1. So if I divide everything by negative 1, am I in business? So I got negative 1 out front. Do I write negative 1? No, I just write negative. What do two negatives become? Positive d squared. What do two negatives become? Positive 5d. And what do two negatives become? Positive 24. Now, is that a trinomial we should check? Sure. So we check. What would I have to multiply to? 24. What would I have to add to? 5. Does it exist? 1 and 24. Nope. 2 and 12. Nope. 3 and 8. Possibly, right? Except look, positive, positive. So it has to be 3 plus 8, doesn't it? Does that make 5 or does that make 11? 11. So this guy is done here. There is where he is done. Everybody cool? So we've covered one layer of trickery, right? Let's go to the next layer. J is the next step. What's different in J? There's two what? There's two variables. When there was one variable, we had x and x, correct? So you guys are smart kids. I must have v and v, yes? And if there's a second variable, what must I have over here? B and b, because b times b, I'll get my b squared. Right? Does that make sense? Okay, do you think anything else changes? Does anything else change? Of course not. What do I got to multiply to? Negative 20, and what do I got to add to? 19. This is the one everybody screws up. Because what is the numbers that work? 1 and 20. Everyone forgets 1 and 20. How does 1 and 20 get me to positive 19? Plus 20 minus, do I write 1? So it's done. Everybody good? Okay, now you try K, because K is exactly the same as J. You should be able to do it now. Negative, so it's plus and minus. Look at how much work you can do without actually doing any work. Now I'll let you think about it for a minute. It's a tricky one because it goes beyond the 12 times table. What do I got to multiply to? Negative 28. What do I got to add to? 12. 14 and 2. Which goes where to get positive 12?
The 14 goes first, and then the 2.
Because 14 minus 2 is 12. See how easy it is? Okay. Look at L. New level. What's different?
Because it's variable.
There's too many variables, aren't there? And there's a cube. Are we allowed to have cubes? Is there a cube anywhere in our general form? Are we allowed a cube? No. So that tells us I got to get rid of that cube. What gets rid of things? Not subtraction. Divide. So I need to get this b down to at least a square, don't I? So if I divide by b, am I cool?
Yeah.
Can I get a b out of here? Yup. Can I get a b out of here? Yup. So now I have a GCF, don't I? What is it? The GCF was b, so I write b and then I write my answers. B's are gone. A squared minus ab minus 20b squared. Correct? Now, can I forget about Mr. B? No, he stays there. Does this guy look like something I should check?
Yeah.
Sure. What do I got to multiply to, Vanessa?
20.
What kind of 20?
Negative.
Negative 20. And what do I got to add to, B-Rad?
1.
Negative 1. What is it? Will 1 and 20 get me there? 2 and 10. 4 and 5.
Yeah.
Yes, I need negative 1, so it must be a plus 4b and a minus 5b. Cool? Okay. This should almost be the end of your guys' page, yeah? M is your last one, correct? Look closely at it. Does it look similar? But what's different? It's x to the 4th. Now when it was x squared, it was x and x, right? Because x times x is x to the 2. What would I break this guy into? X squared and x squared. Is that x to the 4th?
Yes.
So I'm okay, right? That deals with the one difference, correct?
Yes.
And everything else the same, isn't it?
Yeah.
So do it. What do I got to multiply to? 50. And what do I got to add to? Negative 15. What is it? Negative 10 and negative 5. Is negative 10 minus 5 negative 15? Is negative 10 times negative 5 positive 50? Done. Easy peasy, yeah? All right, on your outline, page 166. And that will be it for tonight.